Welcome to this walkthrough of the main features and functions of the Ditch Assist Android app. You can download the app from the Google Play Store. Note that the app is designed to run on Android tablets and may not function correctly on phones. When the Ditch Assist control module is powered on, it will create a Wi-Fi access point. From your Android tablet, select the Ditch Assist Wi-Fi network. The Wi-Fi password is 12345678. Connect to the control module. Note that the Ditch Assist control module does not have internet connectivity. Your device may give a warning similar to this. It's important you click Always Connect to prevent issues now or in the future. Next, open the Ditch Assist app on your tablet. Click on Connect Wi-Fi to connect the app to the control module. Once connected, you should see information populate on the left of the screen confirming a successful connection and that your GNSS device is correctly configured. Tap the Follow GNSS checkbox to zoom the map to your location. Let's begin our demo by running a survey. With the Survey tab selected, tap Start. Now you can begin to drive along the proposed route or center of the area you want to grade. If you are creating ditches or tile runs, the route can be straight or curved. If you want to create a plane to grade a large area, drive in a straight line through the center of the area. Hit Stop when you have completed the survey. With our survey complete, let's design a best fit drain. Tap on the Slope IQ button. The first screen you see in Slope IQ lets you specify a minimum gradient and, optionally, depth guidance. The minimum gradient refers to the minimum slope that is maintained throughout the drainage route. Typically for surface drainage, this will be set at around 0.05%, and for tile drainage around 0.1%. Slope IQ automatically adjusts the default value to be either positive or negative depending on whether the survey began at the outlet. Tap one of the buttons to simulate adjusting these parameters. Next, tap the Propose button to see the proposed solution. The best fit design is displayed on the graph. The orange line represents the existing terrain along the survey route. The green line is the proposed route. You'll see here it follows the natural terrain where there is sufficient grade, and then maintains the specified minimum grade wherever the terrain would hold back water. The brown line is the depth guide. This line is 6 inches below the surface based on our settings. This helps us visualize how deep our cut would be. In this case, the green line does not cross the brown line, so we know we wouldn't be scraping more than a few inches. In the real app, you can make adjustments to the parameters and hit Propose again to see the results. Once you are happy with the design, tap the Apply button. Now we are ready to implement the best fit design. Tap on the Implement Slope IQ button on the Survey tab. This loads the design into the grading engine and opens the grading screen. Drive to any point along the original survey route and tap the Start button to begin working. As you drive along the survey route, you'll see your 3D location on the design graph, and the arrows will illuminate showing the current elevation compared to the target elevation. If you are using the full automation kit with PWM hydraulic valve, the Ditch Assist control module will operate the valve to automatically control the blade elevation. When working in the field, you can stop and start as required, and you can drive in either direction along the original survey route as you work. To move to the next part of the simulation, click Stop when ready. Next, let's take a look at how you can fully customize the design in Slope IQ. This is a great feature for filling low areas along the route or designing simple tile drainage runs. Tap on the Survey tab to return to the survey screen. With the automated design displayed, the Customize button becomes enabled. Tap on it to open the Design Customizer tool. To begin editing the design, tap Start. Note that when we create a custom design, the entire original automated design will be deleted. If you don't create a custom design for the entire survey length, then you'll essentially shorten the survey. To create a custom design, you'll add points to the profile graph that will become the new design profile. First, tap the Add button. With the Add button highlighted in orange, you are ready to add the first point. We will begin at the upstream end of the survey. Tap on the location illustrated to add the first point. Now, repeat the same process to enable the Add button, then add the second and third points. Let's assume we either tapped the wrong location, or decided to adjust the location of the third point. To do this, first enable the Move button. Now, tap on the location you'd like to move the point to, as indicated on the screen. We've now moved the third point, and the design profile has been updated accordingly. Continue to add a few more points to complete the custom design. In this case, we will aim to fill in the low spot at around 250 meters, and this will allow us to keep the outlet depth more realistic at the field edge. Once you are happy with your custom design, tap the Stop button to stop editing and save the design. Then, tap Apply to replace the automatically generated design with your new custom design in SlopeIQ. Now, follow the same procedure as before to implement the custom design and begin working. You'll now see your custom design on the profile graph, and the target elevations will be based on this. When ready, click Stop to move to the next part of the simulation. Next, let's take a look at the built-in simulator function in the Ditch Assist app. This is a great tool to practice using the app, and our dealers also use it very effectively to demonstrate the system to potential customers. Tap on the 3 vertical dots at the upper right of the screen. The simulator is designed to simulate a connected control module and GNSS receiver. You can't use the simulator when connected to a real control module. You can either use custom waypoints by first clearing the sample points and entering your own, or you can use NMEA messages to simulate GNSS positions. In this example, we will use the built-in NMEA messages, so please tap on the NMEA tab. We've pre-populated the simulator with some simple GGA messages. You could delete these and paste in your own if you wanted, but for now we'll just use these. Tap Start to enable the simulator using these GGA messages. Enabling Follow GNSS will zoom you to the simulated location, and you can then simulate using the system in the field. The most critical setting to make sure you enter correctly is the transport mode blade height. This is the height of the blade or cutting edge above the ground when the implement is lifted in its field transport position. When you drive a survey, we assume the implement is in this position, and subtract this distance from the survey elevations to accurately calculate true ground elevation. Tap on the setting to change it. Next is the GPS to blade height setting. Usually, this will be the measurement from the GNSS antenna to the blade or cutting edge, but you can also adjust this value to calibrate the displayed elevation to a known benchmark or previous survey. Tap on the setting to change it. You may also want to adjust the response sensitivities for manually raising and lowering the implement from the app. These relate to the raise and lower buttons on the grading screen. In this example, let's assume that holding the raise button doesn't lift the implement quickly enough. Tap on the setting to increase the hydraulic output. The first times you run the system with hydraulic automation, you may also need to make slight adjustments to the PWM duty cycles. The minimum and maximum valve duty cycle settings control the aggressiveness of the PWM valve. The higher the minimum value, the more aggressive any initial movement will be. However, if the value is too low, there may be no movement for several seconds as the valve ramps up to the maximum value. The default settings work well for many machines, however you may need to make adjustments. Let's imagine we have a small scraper or blade, and are finding the automated movements are too jerky and we sometimes overshoot the target elevation. Tap the settings to adjust the minimum and maximum values. You may also wish to adjust the nudge sensitivity value for the manual nudge function. This is related to the nudge up and nudge down buttons on the grading screen. Where a cut is too much for a single pass, the operator can nudge up one or more times to reduce the cut. Then, on subsequent passes, the nudge back down until the final grade is achieved. Remember, you also have the option of using auto nudge, which we'll cover as well. Let's change the settings so each press on the nudge buttons adjusts the current target by 4 inches instead of 2. You can also adjust the setting for Auto Nudge Maximum Cut. This is the maximum depth per pass that your implement can comfortably handle. For example, a value of 2 inches means that on the first pass, your depth will never be deeper than 2 inches. On the second pass, the depth will be a maximum of 4 inches, and so on until the final grade is achieved. Next, let's look at how we can add some of the most commonly used overlays to the map screen. Tap on Manage Layers above the map to begin. Then, tap on the Add button. First, let's add a KML layer, such as a flow route model downloaded from the Ideal Drainage Mapping portal. Navigate to the folder containing file, usually your Downloads folder, and select it. Then, click the back button on the tablet to return to the main screen and load the map overlay. Here's the KML layer overlaid on the Google Map imagery. Let's repeat the process for a different overlay. This time we'll add a georeferenced image overlay, such as a map we georeferenced using the tool on the Ditch Assist website. Note that for a georeferenced image overlay, we must select both the image and the accompanying world file that contains the geolocation information. Here, we have a JPEG map image, along with the accompanying JGW world file. With both selected, tap Select. Finally, let's learn how to recall a previous survey and use it in SlopeIQ. This is useful if you are working over multiple days. We load the prior survey in a similar manner to adding map overlays, only this time you'll select XYZ raw file as the type. By default, Ditch Assist saves all surveys and work data in a folder inside the Documents folder on your tablet. You may need to navigate to this location, and in some cases you may need to install a file manager app such as CX File Explorer to allow this location to be accessible. Once the survey file is loaded, you'll be able to recall it into SlopeIQ as if you had just driven it. That's the end of this Ditch Assist app interactive simulation. We hope you enjoyed it and found it informative. Feel free to navigate back to any section to repeat anything. Please don't hesitate to reach out to us or one of our highly knowledgeable dealers if you need further information or assistance regarding Ditch Assist.